Hello, doctor. My name is Pan Yu Kai. So today I'm presenting my individual part for our COA group project. For this project, I tested my laptop using an industrial standard testing tool called Cinebench 2026. So my laptop uses uh, an Intel Core i7-1355U processor, which has 10 physical cores and 12 logical threads, also known as logical processor. So in this video, I will show you how I set up the tool, how I gather my performance data, and what this result tells us about how the laptop hard work handles heavy work. So let us start with the opening of the Cinebench 2026 or after download and unzip the file, extract all the information. So we can press this Cinebench. After that, it will show up like this. So to get the advanced data required for our computer architecture project, we have to turn on the hiding timing features. So I do this by going to the top menu, clicking file here, and checking advanced benchmark. This unlocks the minimum test duration setting. So for workload A, which tests how the system handles heavy multi-core tasks, I choose 30 minutes and click on start on CPU, multiple threads, follow the lab guide. And for workload B, which tests a single core running by itself, I set the timer to 10 minutes and then click start on CPU, single thread, not the single core because we are comparing multiple threads and the single thread. So I can't showcase the demo for the workload A and B because it takes up a long time. So I will just presenting my screenshot of the result. So now let us look at the number for workload A. So this test is designed to make every single core and thread on the CPU work at 100% capacity at the same time. So since this version of Cinebench does not save automatic text logs in our folder, so our total CPU execution time, I will estimate is exactly the 1,800 seconds from our log 30-minute test loop. So at the end, 30 minutes, my laptop finished with a raw multi-thread score of 1,112 points. So with this score, I calculate our first metric, which is the task level throughput. So the task level throughput, which can tell us how many points the CPU can generate every second. So after calculate, it will become 0.618 points per second. So next, I've calculated the pipeline saturation efficiency. So this tells us how the 12 threads work together compared to just one single thread running alone. I divided the multi-thread score by 12 threads multiplied by my single thread score of 273. Why 12 threads? Because my CPU is having a 12 logical processor. And then the 273 points is I get from the workload B. So after that, an efficiency of 33.94% is quite far below a perfect 100% baseline. So this will prove that the processor ran into heavy bottlenecks when all threads were working together. And then after that, I will going for the workload B here. So this test is completely different because it stops all multi-core teamwork and isolate the work to just one single execution thread. Running this 10-minute isolated test gave us a score of 273 points. Because Cinebench does not show real-time hardware data on its own, so I will use the window task manager to monitor the processor speed. So basically it look like here, and then I have captured some screenshot of it. So at the very beginning, here I got the active core hit a maximum boost score of 3.07 gigahertz. However, as the heat built up over the 10 minutes, like this, the speed slowly dropped from 3.07 gigahertz down to a steady 2.9 gigahertz. So this is a speed drop of 0.17 gigahertz caused by the thermal pressure. So most importantly is looking at my task manager graph confirm the presence of core shifting that we can see here. So the 100% load spike didn't stay on just one processor grid. It jumped around from core to core. This directly proved that the window thread scheduling algorithm was migrating the heavy tasks across different physical cores to spread the heat around the CPU and avoid making any single spot on the processor too hot. So I will go for the comparison part. So for the comparison, when we look at both tests side by side, so we get a great lesson in computer architecture. So this why was our efficiency only 33.94% when all threads were running. So this happened because my Intel i7 processor has a hybrid design with two strong performance processor and 8 weaker efficiency cores. So workload B runs beautifully because it's based on a strong core. They will like turn around the strong core, but workload A forces passes onto weaker cores, which will record and process the data much slower. And then all 12 threads running at once, they experience resource fighting as they scramble to get data from the shared resource pool. And this project taught me that real computer speed isn't just about having high core number on a specification sheet. So real performance is shaped by physical limits like heat management, how the operating system share tasks, and how the hardware automatically slow down its on-clock speed to stay safe. So, and then that's all for the video presentation. And thank you very much.